Hi, if you want to do a gene expression analysis based on RNAseq data, then you have to learn a few things. First of all, data can be in three different formats. One is FASTQ, it's raw sequencing data where you still have to do the rest by yourself, or it is a tab data. It's raw data generated by star mapping tool, or very often it is a data table compiled by authors and uploaded to NCBI GEO. Out of the scripts, it's HR on DSEQ2 nearly all the time, so there is not a great variety of scripts available for this business. The process is rather primitive. You go to NCBI GEO as usual, you see some links and you download the expression data from the site. For instance, you call this number 133281, you have the data, 36 samples for hematopoietic stem cells from human, young and aged, also MDS patients. And all the data are compiled over here in supplementary file, and upon clicking on download, you download it, and then it is ready for use. The downloaded file is a zipped text file. You can have a look at it and see that, as I said, it's a text file with all data in columns. After download, you simply open R script and use a function read CSV, for instance. And there are also many different read options like CSV, CSV2 if it is if decimal is comma, not dot, and column separator is semicolon, and delim is often used, and table can be done, etc., etc. Pay attention that sometimes you have Excel files as a data table. Then you can use a read Excel package from tidyverse, or it can be XLSX library, and example is given in site STHDA. You can read from there. But except for first line that you read XLSX file, the rest is pretty trivial and as usual. The information about samples is rather limited. Sometimes authors provide it as a separate sample information file, but there is a common place where you should find the sample information for sure. It is this series matrix file, which is also soft formatted family file. You can reach that file by GeoQuery, which you used for microarrays. Only in case of microarrays, you get both sample information and the data. In case of RNAseq, you get only sample information. There are more options like get supplementary files or get geo files. It's simply download via the script, not very exciting. But this get geo option is pretty useful. That's probably universal way to get the information about samples into your script, so use it. If you want to do mapping yourself, if you are not happy with what you can download, then it's pretty long way and you better rely on Linux workstation. I told you before that you can install star on Mac. but I must admit, after inspection it appeared that my installation has a bug which I still have to resolve. This bug could not open input file geninfo tab is well described. It also well documented on the GitHub Alex Dobbin site. Exactly the same story, pretty long. Sometimes people could resolve it, sometimes they couldn't. So far I couldn't make it. FASTQ files can be accessed via this link, SRA run selector. You click on it and then you are on a page where the same samples are listed, only in this case there are links to FASTQ files. You select them and download, but pay attention, they are huge. You need lots of space and memory on your computer. If you do it yourself from sequencing, then pay attention that the short reads, and Illumina is a short reads sequencing, is good. It's ideal for the gene expression analysis because you measure gene expression by read counts per transcript, and it doesn't matter how long is the transcript. What matters is how many are they per transcript, and therefore if you have a 50 nucleotides read, it's already good enough for a quality alignment, so you don't make mistakes with alignment, and it is economic. You don't waste your resources on needless extra sequencing for the sake of a bigger length. Patent is also good. It's you have advantage of knowing better your splicing events. What star generates when you do it is a bump file, and it is useful when you want, for instance, information about genomic polymorphism or some mutations or allelic or genotypes or haplotypes, well, whatever. But for expression analysis, it's only tab file, which is, as I said, read counts per every transcript in a genome. You can find those kind of data on NCBI GEO as well. Here is an example. In supplementary file you see only one item, but on clicking on it, it expands into a series of files. You download it, so then you untar it on your computer and you can have a look in one of them, and then you see this sort of long table where you have a first 4 lanes, sum total numbers for mapped reads, unmapped reads, then one strand mapping, other strand mapping, and unstranded mapping. Note that it's not additive of one another, it's different algorithms of counting. And the first column is the ensemble gene numbers. That's what a star mapping tool generates as the output. Never unzip Gazette. Gazette can be read by R scripts. You load library HR, then you set directory where your multiple files are located. Then you can also ask list me those files and you have this list. Also you can indicate the pattern. I want tab GZ only. And then you say data table is read DGA, that's the function in HR, which will read all those files and generate a data table. And I also ask to skip for first 4 lines in every file because it doesn't belong to a data table. So after reading with read DGA, you simply, it's a complex variable, There is some primitive information about files. Out of this you get only pure counts table declared as df, and here you are. In this particular case, row names are ensemble gene numbers. This is good because it's always unique, no problem, declared as row names. In this particular case, if I load data table generated by somebody, you see this particular story that the first column is your gene names, and if you say, okay, I want to declare it as a row names, then it's an error because they are not unique. And this sort of glitches are pretty frequent in public data, so don't be upset, be ready to fix them. In this particular case, you have to remove duplicates and then use the rest of it with only unique names, which is a bit of a data loss, but there is no other way. And note that all data tables which you see on NCBI GEO are compiled by authors, and they do not adhere to any strict rules. Every table can be different and sometimes not that easy to use. Sometimes you will be surprised or not. RNAseq data also have a button GeO2R, which allows you to analyze it online. And if you do it exactly as you do it for microarrays. I mean, options are slightly different, but the principle is the same. And after copy pasting generated R script, you will find out that they rely on DSEC2 library. There is a good reason for it, which can be explained later on. That's more or less the introduction to the business.